Around 10 to 20 billion years ago, there was an explosion referred to as the Big Bang, which caused the rapid expansion of very dense matter, creating the universe. The early atmosphere contained gases, which together formed masses of organic molecules and eventually formed the universe. The Earth began as a gaseous cloud, which over time became solid after being changed as a result of gravitational forces, heat, radioactivity, and meteorites. As the Earth slowly cooled from 1000 to 100 degrees, the heavy molten rock sank to the interior, becoming the core, and the lighter rock rose to the surface, forming the lithosphere and changing the thin primordial atmosphere. On this page are some key terms and definitions which we would do well to make yourself familiar with in order to better understand our presentation. Conditions of early Earth made organic molecules which led to the development of materials that are constructed of those and are the building blocks of life today. The cooling of the Earth and atmosphere meant that there was a change in the atmosphere, allowing the oceans to form and small land masses to surface. These land masses in turn revealed volcanoes. And volcanic activity led to outgassing of basic elements such as water, methane, ammonia, hydrogen, nitrogen, and carbon dioxide, releasing them into the new forming atmosphere. These were the first basic organic molecules, and these basic elements are in most compounds in the world today. Radiation and electric storms resulting from no ozone layer and the easily penetrable atmosphere of the Earth created large amounts of potential energy pouring into the Earth, making it rich in hydrogen, allowing chemical reactions between hydrogen and organic molecules to be easily done and readily available. The anoxic atmosphere meant that there was no oxygen available to react with the metals in the ground, allowing the preservation of metals due to the inability to rust. This also meant that the world could not yet support living things, and why the development of these early organic molecules was integral for the world today. Rain was also important in the early development of the Earth, as it cooled the Earth's surface, washed organic molecules into bodies of water, allowing them to become high in minerals, forming fertile environments for further reaction and development. Organic molecules were useful because between them and the hydrogen they were able to put and create large masses of new elements through chemical reactions and continuous development of the Earth. The elements that were present were important and still make up major components of compounds found in the world today. Overall, the relationship between organic molecules and the conditions of early Earth depicted how the organic molecules were the building blocks of all matter. The development from basic organic molecules to complex organic molecules is the evolution of all matter through chains of chemical reactions. Organic molecules built up and allowed the formation for early Earth and then continued to develop to allow the Earth to support life today.
Created using Powtoon.